Hello, I'm going to show the implementation process of DSISLM using Xilinx system generator blocks. My name is Somaya Mohammadi from Electronic Department of UPM. I open my block diagram which I created in model window of MATLAB using Xilinx blocks and also other blocks. As you can see, we have different types of blocks here, and these blocks, the small yellowish color, are indicating the area that I want to implement in FPGA. The others are necessary for testing the input signal and the dummy and phase and phase. As you can see, we have two phase. So here I'm generating two candidate signals, and I have two output which will show the two candidate signals with two PAPR, and then I will choose the one with the minimum PAPR. Okay, the other type of blocks that I have are these yellow ones. Here I convert complex format to real imaginary, and at the end I change it to complex again. In this block I show you a slow process. Okay, here if I assume that number of subcarriers are 256, from 201 to 256 will be indicated for dummy signals, so the process is shown here. And this block, which I call it CSLM, I click on it. Here are two lines for two candidate signals, complex multipliers and I50. I showed previously that I generated these I50s using Excel DSP tools, and the complex multipliers I generated using Xilinx block set. That's the reason why they have Xilinx sign on the background. Here is the process using simplified process using the Xilinx library simple blocks. So yeah, the complex multiplier is generated this way. Okay, to see the performance I run it. Here we can see that is working. Okay, I supposed to have output out and out one in form of matrix in my MATLAB workspace, which I have. Okay, as you can see, the number of symbols are about 10,000. So as I mentioned in my thesis, I will have unwanted zeros in the output. So I should select the piece that doesn't have those zeros. To do that, I have this program. I run it. Okay, so I will have out 2 and out 3 for more accurate result. Yes, out 2 and out 3. As you can see, 1500 something is reduced from previous matrix. Another program that I have is for calculating PAPR. I run it. This takes the most time. I also calculate the PAPR of the original input to compare with the one I have done the process, and also for plotting the CCDF figure. When this is performing, I try to explain some of my parameters. As you saw here, I used pre-created data for my input and dummy, and also phase. This is for simplification, but also I can put data generator and a modulation block, same as previous test that I showed. And here you can see the length of data is 256. So the dummy is 55. Let's see what other program I have. I check it is still running. Okay, for sampling process, what I can say is that in my block diagram I put the sample time for 10,000, and then for the select, as I mentioned previously, I reduced 1546 of that, and then for PPR calculator I changed it again to 10,000, and the number of symbols is 10,001. I check it, it's still running. The result of this demonstration will be similar to the cosim. Cosim is, if I open that block, I can show you that one. Okay, this one. This one is the block which is called JTAG cosim. When I run this program, this data will be passed through FPGA board, and then I will get the results. What I just said is that my result in this demonstration will be similar to that one. Okay, I check the performance is finished, so I will have two PAPR and PAPR1 here. Yes, I have it, 11 something as I expected, and PAPR1 9.26. As you may notice, this performance is done for only one iteration. If I want to have more accurate data, I should repeat it for implementing iterations. Okay, I have another thing here for plotting the CCDF figure. I run it. Okay, this shows roughly what is going on, the original CCDF and the reduced one. As you can see, 11.12 was reduced to 9 something. Okay, thank you very much.